Good morning, class. Just to welcome you to yet another session in our Cybersecurity Essentials course. Today we'll be looking at Chapter 4, the Act of Protecting Secrets. The Act of Protecting Secrets. Now, the concept we are looking at has to do with cryptography, access control, and obscuring data. Okay, now cryptography is the science of making and breaking secret codes. Cryptography is a way to store and transmit data so only the intended recipient can read or process it. Modern cryptography uses computationally secure algorithms to make sure that cybercriminals cannot easily compromise protected information. The history of cryptography started in diplomatic circles thousands of years ago. Messages from a king's court took crypted messages to other courts. Occasionally, other courts not involved in the communication attempted to steal the messages sent to a kingdom they considered an adversary. Not long after, military commanders started using encryption to secure messages. Each encryption method uses a specific algorithm called a cipher to encrypt and decrypt messages. A cipher is a series of well-defined steps used to encrypt and decrypt messages. There are several methods of creating ciphertext, and that is transportation, substitution, and one-time path. So the point we are looking at here in the overview is that cryptography has to do with encryption or securing of information as it is being transmitted, as it is being sent across the network, or as it is being sent from one device to the other. So it is important for us to understand that what we are going to be centering on is if you have a data, if you have a record, and you are sending it either via internet or via mail or whatever means you are using, somebody can access that information and probably alter the content or change its destination. So cryptography has to do with us being able to secure it. And we have basically two types: the systematic algorithm and the asymptomatic algorithm. And these are the two classes of the encryption algorithms that we are going to be looking at. These algorithms for systematic use same pre-shared key, sometimes called a secret key pair, to encrypt and decrypt data. So both the sender and the receiver usually have this particular key. Is for instance, when somebody wants to send you money from abroad and uses Western Union transfer, and you go to receive the money, you must have the password, you must have the pre-shared key to be able to receive this particular information. Now, asymmetric algorithm encryption algorithm use one key to encrypt data and a different key to decrypt it. So you see the difference between the symmetric and the asymmetric is that the symmetric, we use the same key that is used to send, to encrypt, is the same key you use to decrypt. But in the asymmetric, they use different keys. So one key is public and the other is private. In the public key encryption system, any person can encrypt a message using the public key of the receiver. And the receiver is the only one that can decrypt it using his private key. So parties exchanging secure messages without needing a pre-shared key in this particular case. Alright, but in most cases, the asymmetric is more complex than the symmetric. Now, symmetrical encryption process has to do with the algorithm that use pre-shared key, as we have said it, to encrypt this data. And the method is also known as the private key encryption. So numerous encryption systems use symmetric encryption. Some of the common encryption standards that are used symmetric encryption includes this that we're looking at. The 3 des, triple des, the IDA, and then the AES. Okay, and remember, we're talking about the key that is used to encrypt is the same key that is used to do what? To decrypt. So if you have probably, let's say, a wireless access point, and you set up your access point and then you configure a particular password, and the password that you configure is what people are going to use to decrypt and gain access into the particular access point. So that's the idea of the pre-shared key. So the triple des digital encryption standard is a symmetric block cipher with 64-bit block size. Okay, so the triple des uses what? 64 bits. So it encrypts data 3 times and uses a different key for at least one of the 3 processes, giving it a cumulative size of 112 to 168 bits long. So you see, the secret of encryption is that the longer your encryption length, the more secure your encryption is. So IDA, which stands for the International Data Encryption Algorithm, uses 64-bit block also, and also 128-bit key. So the IDA performs 8 rounds of transformation. You see, the triple des uses what? 3 rounds. All right. The IDA uses up to 8 rounds of this encryption. All right. And then each of these on each of the 16 bits that results from dividing each 64-bit block. Okay. Now, the next one is the AES. The AES stands for Advanced Encryption Standard. Advanced Encryption Standard. And it has a fixed block size of 128 bits with a key size of 128, 192, and 256. The National Institute of Standards and Technology approved the AES algorithm in December 2001. And the US government uses this to protect classified information. Now, in our own case, sometimes when you're configuring your wireless access point or you're configuring your router, you come across this AES algorithm on your laptop or on the router so that you can be able to use. Now, all these 3 that we looked at are for what? For symmetric. Now, let's look at the one for asymmetric. The asymmetric encryption is also called the public key encryption. Uses one key for encryption that is different from the key used to decrypt it. So a criminal cannot calculate the decryption key based on the knowledge of the encryption key, and vice versa. In any reasonable amount of time, the asymmetric algorithm may include either of this. Alright? The first one is the RSA, the Rivers Shamir Adleman, which uses the product of 2 very large prime numbers with an equal length of 100 to 200 digits. Wow. So browsers use this as a RSA to a secure connection, especially when the browsers are using what do we call it? HTTPS. Okay, HTTPS. So they use these public keys to be able to secure the exchange of data between when you are submitting the data and when it's stored. All right. The second one is the Diffie-Hellman, which provides an electronic exchange method to share the secret key. Secure protocols such as SSL, all right, or secure socket layer, transport layer (TLS), secure shell (SSH), and internet protocol security. Now, the Diffie-Hellman is one of the very common ones that we use to remotely gain access to devices. You want to log into your router remotely or log into your switch remotely, log into your device remotely and securely. All right. Most of the times we use either SSH, all right, to connect. Then we have the ELGAMA, which uses the US government standard for digital signature. So this algorithm is free to use because no one holds the patent right. All right, it's also a public key encryption. Then you have the elliptic curve cryptography, ECC. It uses elliptic curve as part of the algorithm. All right. In the U.S. National Security Agencies, it uses ECC for digital signature generation and key exchange. So in this one, it has to do with security of documents, like signed documents that are digitally signed documents, signed certificates or digitally signed certificates, and things like that. All right. So let's compare the symmetric and the asymmetric encryption. All right. It's important to understand the difference between the symmetric and the asymmetric encryption methods. Symmetric encryption systems are more efficient and can handle more data. Right? However, the key management with symmetric encryption system is more problematic and harder to manage. Okay, that is for the one of the differences for the symmetric. The asymmetric cryptography is more efficient at protecting the confidentiality of small amount of data, and its size and speed make it more secure for tasks such as electronic key exchange, which is a small amount of data rather than encrypting a large block of data. Right? So, what are we saying here? We are saying that one of the points we need to look at is that symmetric systems are more efficient and can handle larger amount of data, but asymmetric are more what secure. All right, especially when you are dealing with small amount of data. All right. Now, another difference is the application. There are many applications for both symmetric and asymmetric algorithms. A one-time password generation token is a hardware device that uses cryptography to generate a one-time password. A one-time password is an authentically generated numeric or alphanumeric string of characters that authenticates a user for one transaction of one session only. The number changes every 30 seconds or so. The session password appears on a display and the user enters the password. So, the electronic payment industry uses ADS, the operating system uses TDS, and then most encryption such as NTFS and AES. Now, for those of you who do a lot of online banking or internet banking, you will agree with me that anytime you are either doing an online purchase or you are doing a transfer or you are doing anything online, it will require you to enter a token. So you see, this token is just a code. So it is that token is being based on cryptography. Okay, so we are saying that one of the applications is when you are using this token. All right, and we said that both symmetric and asymmetric algorithm uses it. All right, so like the OTP that we know, we call it OTP, one-time password. Okay, is an example of how it is being applied. Another way it's being applied is four protocols use asymmetric algorithms. One is the Internet Key Exchange, which is a fundamental component for IPsec and VPNs. Now, this particular application, this particular feature is used when organizations want to exchange communication between one of their sites with another site that is remotely located. So if your organization has an office in Jos, and then have another office in Abuja, and then have another office in Lagos, and you are all supposed to be accessing the same resources or applications that you have in your company, and you exchange this information over the internet. Now, this is where this particular application comes into play, because VPNs, virtual private networks, are one of the very secure way of exchanging information or accessing resources, local resources remotely. All right. So the next one is the SSL, Secure Socket Layer. Now, which is a means of implementing cryptography into web browsers. So if you go to your bank website, you see they will put the HTTPS, all right, or any other website that you want to make purchases, or any other website that you want to log in to submit information or to log in or whatever it is. Once you see that, it's one of the ways that you secure your website, so that information that you enter is not clearly seen, is properly encrypted. Then another application is using SSH. SSH is secure shell, which is a protocol that provides secure remote access connection to devices. And that is what we explained earlier. So you want to remotely gain access to a particular device that is located somewhere, you use SSH. All right. And so that way, you can either access it using Telnet, which is terminal emulation, or SSH. But Telnet is not secure. And so that's why SSH is highly encouraged for you to use. Then we have the PGP, we call it the Pretty Good Privacy, which is a computer program that provides cryptographic privacy and authentication to increase the security of mail communication, especially when you have a company that gives you systems, all right, to install your systems, to install your mails. You have Thunderbird, you have Outlook mails, or you have all these mail clients. Okay, and as you don't do this exchange, you do these messages, it helps you a lot to secure your information. We're still looking at application. We talked about VPN and IPsec. We're still there. Okay. Now let's look at access control. Now we have different types, one of which is the physical access control, the other is the logical access control, and another is the administrative access control. So the physical access control actual barriers developed to prevent direct contact with systems. Okay, direct contact with systems. So the goal is to prevent unauthorized users from gaining physical access to facilities, equipment, and other organizational assets. So physical control determines who can enter or exit, or where they can enter. So when you go to certain companies or organizations and you see biometric doors, all right, before you enter a particular office, you need to use biometric doors, or you want to enter a server room, or you want to enter any secure area. Okay, so you use this to control access into restricted locations, in buildings, in offices, even in the home. All right, so that one has to do with the physical access, the devices that you use to put in barriers so that people can be able, you can control the access of people into this particular platform. Then logical access control, hardware and software solutions used to manage access to resources and systems. These technology-based solutions include tools and protocols that computer systems use for identification, authentication, and authorization. For instance, if you go to your organization or you visit another organization and they have internet access, you want to gain access to this internet service, and you are being told that you need to log in with your details. You need to gain access with your details. So to be able to log in with your details becomes a problem. So the point here is that how are you able to manage it? How are you able to manage access to certain restricted resources, maybe access to the internet or access to a particular portal or access to a particular database or access to any resource, even the computers. How do you manage that? That all those work under logical control, where you put in username and password, or where you create what we call the AAA authorization, authentication, and accountability. A radio server, for instance, where you have a pool of database of users, and then you control what they can access within the organization and what they cannot. Now, the third one is the administrative access control. This has to do with policies and procedures defined by organizations to implement and enforce all aspects of controlling unauthorized access. So administrative controls focus on personnel and business. So you see here, it has to do with what? Policies. It has to do with policies and control and procedures that is set by top level management. All right. And these policies and controls have to, procedures has to do with the implementation or enforcement of security control in so many things: access to resources, access to physical devices, what you can do on the network, what devices you can use and what you cannot use. All those things are policies. Okay? And they all fall under types of access control. Now, what are some of the strategies that we can use? The first one is called the mandatory access control, which is the MAC. And it restricts the actions that a subject can perform on an object. So a subject can be a user or a process. An object can be a file, a port, or an input-output device. So an authorization rule enforces whether or not a subject can access an object, right? The second one is the DAC, discretionary access control. All right, the first one is the mandatory, the second one is the discretionary. So that grants or restrict object access determined by the object's owner. As the name implies, control are discretionary because an object owner with certain access permission can pass on those permissions to another subject. All right. The next one is role-based access control. So you see, the definition has to do with the name. The mandatory, you see, makes it mandatory to determine who can access what. Okay, whether or not they can access. Now, discretionally has to do with giving access based on certain discretion or conditions. All right. Then role based has to do is based on the role of the subject. All right, or the roles based on the job function within the organization. So this role base has to do with the access control or the permissions you are giving based on your job description. So different people have different grant access and permission. Then you have the rule-based access control, and it uses access control list to help determine whether to grant access or not. So a series of rules contained in the access list are shown in the video. So these are basically some of the strategies that can be used for access control. How about identification? Identification enforces the rules established by the authorization policy. Okay? Now, the subject requests access to a system resource. Every time the subject requests access to a resource, the access controls determine whether to grant or to deny access. So cybersecurity policies determine which identification controls should be used. The sensitivity of the information and information system determine how stringent the controls are. So the increase of the increase in data breach has forced many organizations to strengthen their identification. All right. Okay. So we are saying here that the sensitivity of the information and information system determines how stringent the control should be. All right. So if you walk into a bank, the kind of securities that we have on their records or data is different from that of a hospital, is different from that of a school, and is different from that of a military base, for instance. Okay? So the point is that the sensitivity determines the control. The increase in data breaches has forced many organizations to strengthen their identification control. Okay? Now, most of the times you see, like what you see here, these are like chips that are placed on the ID cards that contains a lot of our information. Whether you are using an ATM card or you are using an organizational identity card or whatever it is, it comes with a chip that once you insert, it can read the information and verifies who you are. Now, what are some of the authentication methods? What you know is password phrase, pins. These are just examples that we use on a daily basis, all right? And what you have on your hand to use maybe are smart cards and security key, all right? To enter your offices, you want to enter an office, you use a smart card, or you want to use get access to money, you use your ATM card and things like that. And who you are unique physical characteristics, such as your fingerprint or retina or voice that identifies specific biometrics. So you can use your fingerprint to authenticate you, or you can use the retina in your eyes to authenticate you, or you can use voice control or whatever it is. But the point is that something that no other person does have. Then there is also the multi-factor, all right, that uses at least 2 or more methods to verify. Sometimes you see you ask you on your password and then maybe your voice authentication or your fingerprint or something. All right. So these are some of the methods that can be used. How about authorization? Authorization controls what the user can do on the network after successful login. All right. Authentication tells us how we can connect. All right. Or who should connect, who is authorized to connect. Then authorization has to do with what the person can do after he has successfully logged in. All right. This has to do with a lot of roles and the job functions and things like that. So after a user provides his or her identity, the system checks to see what network resource the user can access and what the user can do with the resource. Okay, so the authorization users is a set of attributes that describe the user's access to the network. All right, so after you have been authenticated, then you tell us whether what you can do based on that. Then accountability, all right, basically it has to do with keeping of records of what you have done on the network. So based on the roles that you have been assigned, the system keeps track of all that you have done or all that you are doing on the network. So accountability traces an action back to a person or process making a change to the system. It collects this information and reports the usage data. So the organization can use this data for such purposes as auditing or billing. All right. So the collected data might include the log in time for a user, whether the user log in was a success or failure, and what resource the user access. All right. So these are the triple A: authorization, authentication, authorization, and accountability. All right. Now, we have different types of security controls. We have the preventive controls, which prevent is to keep something from happening. All right. So you can do preventive control just to make sure that your system is safe. Then you can do deterrent control. Okay, so a deterrent is the opposite of a reward. A reward encourages individuals to do the right thing, while a deterrent discourages them from doing the wrong thing. So cybersecurity professionals and organizations use deterrent to limit or mitigate an action behavior. So deterrent do not always stop this action. So if you break in and you are able to do this that you are not supposed to do, there are certain measures that can be taken against you. Then detective, right? The detection is the act or process of noticing or discovering something. So access control detection identifies different types of unauthorized activities. So detection systems may be very simple, such as motion detectors or security guards, but they can also be complex, such as IDS, intrusion detection system. Then we have corrective control. Corrective controls counteract something that is undesirable. All right, so organizations put corrective measures or control access control in place after a system experiences a threat. Okay, so there is a security breach, and then you find out what happened, and then you now find a way to correct it. Recovery controls is a return to a normal state. Recovery access control restores resources, functions, and capabilities after a violation of security report. Okay, so you see they all go hand in hand. All right, after detection, correction, recovery. Then compensative means to make up for something. So compensative access control provide options to other control to bolster enforcement in support of a security policy. All right. So these are the different types of security controls. Now, how about obscuring data? Obscuring data is like making data to look like something else. That's like masking it. All right. So data masking is a technology that secures data by replacing sensitive information with non-sensitive version. The non-sensitive version looks and acts like the original. This means that a business process can be non-sensitive data and there is no need to change the supporting applications or data storage facilities. Okay, so there are data masking techniques that can use ensure that data remains meaningful but changed enough to protect it, and that is the substitution and the shuffling. Okay, the substitution replaces data with authentic looking values to apply anomaly to the data records. And shuffling derives a substitution set from the same column of data that a user wants to mask. Okay? Then steganography. Now we have a lab activity on this, but we'll do the lab activity by next class. But what is this steganography? It conceals data. Conceals, that means like hides data, protect data in another file, such as graphic or audio or text file. Okay, So the advantage of steganography over cryptography is that the secret message do not attract any special attention. No one would ever know that a picture actually contains secret messages by viewing the file either electronically or in hard copy. There are several components involved in hiding of data. All right, there is the embedded data, which is the secret message, the cover text, which hides the embedded data, producing a stego text, then a stego key control, the hiding process. So you see, cryptography has to do with encryption, but um, steganography has to do with hiding, masking, all right, making sure that the data is not seen. So data obfuscation is the use of and practice of data masking and steganography techniques in the cybersecurity and cyber intelligence fashion. Obfuscation is the act of making the message confusing, ambiguous, or even harder to understand. All right, so it's all the plan of the disguise. A system may purposely scramble messages to prevent unauthorized access to sensitive information. Software watermarking protects software from unauthorized access or modification. Software watermasking inserts a secret message into the program as a proof of ownership. And then the secret message is the software watermark. It sometimes tries to remove the watermark, the result is non-functional. All right. So that is the concept of the data of execution. All right. Um, so what we'll do is let's try the lab activity for this, and I just hope the time is supposed to stop by 11. Okay, we have like 10 minutes. Let's give it a try and see whether we'll finish it by then. Okay, so just a minute. Let me load. Let me load. I'm launching my VM. So the lab activity is going to be on the VM. So while it's being loading, so let's see the activity. All right. It is using steganography, and the objective is to hide a document within a JPEG file. A JPEG file is a picture file. All right. So we intend to hide a document, and the resources we need a PC with Ubuntu. That's our VM that we are loading, our virtual machine. So what we're going to do, we log in, username Cisco, password Cisco, that's A. Then B, we're launching our terminal. All right, so, okay, still working. Sorry, it's taking a little longer than expected. Okay, while it's still, let's continue. So we're supposed to log in, username Cisco, password. Then we open our terminals. Then at the command prompt, enter the following to change the download directory. So to change to the download directory, so we go to CD. CD stands for change directory. Change directory. Then we type downloads. All right. So let's see now. How far is it done? Almost. It's done now. So the user is Cisco, password is what? Password. Alright? Right? Password is password. Okay. Okay. So we have our desktop. Then we will go to terminal. Right? Then once we enter our terminal, the next thing is we are asked to change our directory. We are asked to change our directory to download directory. So this is it. So we're supposed to just type cd download. Okay, good. So once we have changed, we are in our download directory. Then it says enter the living secret.otg at the prompt. Okay, so this is what we're going to enter. Our goodness, really slow. There's so many processes. Okay, okay. So this is what we're going to enter. It's better now. Where are you? Alright, so we enter. This is an Office application. Okay. So enter this command.
Stop.
What it looks like. Just type with this office secrets.otg. Alright. So you see, it's going to now load the office like when we have what they call it Microsoft Office or something like that. Okay. So for Linux, this is it. All right. So it opens this particular document. So what is the message in the secret.otg document? This is the message. The message is what? The secret document. Okay. So our answer here is the secret document. So say close the secret.otg file when done. Alright, so we close this file. So close this file when done. Right, so I'll close the file. Okay. Enter keyboard.jpg. Right. So where's my right? Sorry. From here. Right. So we type keyboard.jpg. Right. So this is another file that is going to open. It's an image. You see, the other one was an Office document. OTD is the file extension of the document, like let's say .doc or like .dodcx for Microsoft Word or something like that. So OTD is just the file extension, and the name of the file is what? secret. That's the name of the file. This one that we launched. Okay. And then here that this one that we are just opened is a picture. It's an image. Look at it. The name of the image is what? Keyboard.jpg. JPG is the file extension. Okay, is the file extension, and then the name of the file is what? Keyboard. All right, and it's an image. Look at it. We have just opened it here. Yeah. So it says that close the keyboard the JPG file when done. Right. So we have opened the Word document. We have opened the JPG file. So we close it. Done. Okay. We are done with that. Then at the command prompt, enter the following commands. Enter the following command. Where is it? At the command prompt, enter the following command. What is the command? Look at it here. Yeah. We are going to embed. We are going to embed this document on this picture. This document is that .otg document, that secret document. Yeah. We want to embed it inside here. Okay. So, and command to do it. Let's run it. Okay. We are in. We're supposed to be in download. Sorry. CPU download. Okay. So let's just paste the command. Not so. Let's just type it. Okay. So embed software keyboard.jpg, right? Secret.jpg. Okay, it will ask me for password, right? So the password we're going to use is Cisco. Alright, let's see. When comparing your password, use what? Cisco. We enter the password. So I'm using with the capital C. Okay, so Cisco. Cisco. Right. Good. So now it says you have embedded the document secret.otg into the image file keyboard.jpg. Okay. So remember, we are hiding a document. We are hiding what do we call it now? We are hiding the secret document. We are hiding it inside the keyboard picture. So somebody might just see that picture but will not know there's a document in it. Okay. So what's the next? So it says open the secret file, secret.otg and keyboard file. Did these files change? Okay, did these files change? So we're going to open those same files that we opened earlier on, and this was what we did. Right? Where is the dates? The office secret.otg. Okay, this is the file. This is the document, the secret document. All right. Then for the keyboard, sorry, for the keyboard, we'll open it. Type G here on keyboard. Let's go to ampersand. Let's see whether it has changed. So you see, we have we have done this, but is there any change? The files have not changed. The file still remains the way they are. All right. So the question here is asking, did the file change? The answer is what? No. So now verify the hidden file. So we're going to verify the hidden file. So we use the safeguard command. Okay. Very good. Okay. CP download. So save high and info keyboard.jpg, right? Okay. So this is what we've got. The format is JPG. This is the information. The capacity is to try to get information about embedded data. Yeah. So you can see yes. Enter passphrase. System. Okay. Now it tells you that the embedded data is what? Is secret.otd, and this is the size. This is the size. All right, this is the encryption and it is compressed. So what we did was that we just picked this document, compressed it and hide it inside a particular picture. All right. All right, this is it. Sorry, I just went a little faster than usual. I was supposed to go small. So how do you now extract the hidden file? All right, how do you extract the hidden file? So um, uh, extract, extract also keyboard jpg Cisco. Okay, the file secret.otg does already exist. Do you want to override it? Let's say yes. So it has been extracted. Okay, all right. So look at it here. When we run the command, it says it already exists. Do you want to override it? We say yes. Then it has been extracted. So you have extracted the file. You open extracted file with LibreOffice. So could you open the file? Is the secret message the same as before? So let us check it. Let's check it. Remember, we are in downloads. So once I did ls means list. Okay, once I did ls, list for me everything that is in that folder and see our file here that we extracted, secret.otd. All right, secret. So if you open it, we do Office secret.otd. Okay. Oh, so you see the document is still there. The document is still there and it has not changed. Okay. So the question now is, could you open the file? Is this message the same? The answer is what? Yes. The message is still the same. Okay. So that is how to use this particular command. You have an image file, you have a document file, or any other file. You can always securely pick it and then tie it or hide it underneath a particular picture. So on your system, for instance, You have certain documents, but you have a document that you don't want people to access or to know that the document is there. So what you can do now is you pick the document, you hide it behind maybe an image file, and then you encrypt it with a password. And so even if somebody knows that there's a document there, wants to open it, you ask him for a password. But hardly would they even know, because they wouldn't know which picture they saved it into. Okay, so I think this is the lab activity for today. This is the end of today's class. Today is Monday. Sorry, today Monday. Today is Tuesday. Sorry, today is Tuesday. Our next class is supposed to be on Friday, but um, I intend to schedule another class before Friday so that let's see if we can cover